first, a very happy new year to you all. Well, 2010 ended with something interesting, an eclipse of the moon. Not many people saw it, but something was seen from Selsey Beach. Pete Lawrence got some pictures.
The eclipse has definitely started. There's a definite edge darkening on the left-hand side of the moon. This is really getting quite exciting now.
More about that later. Now, volcanoes. It's been said, that volcanoes are the Earth's safety valves. In a way, that's true, but when one goes off, it's not a good idea to be too close to one. Well, remember, our Earth is not the only world to have volcanoes. There are others. Within one of my oldest friends, Peter Cattermole. He is a volcanologist, and volcanoes attract Peter as a jam jar attracts wasps. Welcome back, Peter.
Thank you.
First of all, why have we on Earth got these very active volcanoes and other worlds don't seem to have them in the same way?
The Earth is unique in one way, in that our planet recycles its surface more or less continually. I know what we'll find Io does that too, but in a very different way. Earth seems to retain enough heat and enough water to allow the inside of our planet to have convected for a very, very long period of time. Right from the beginning of the Earth's history, possibly 4,000 million years ago, it's convected, continually recycling the surface. And that constantly brings heat and gas towards the surface. And so our volcanoes have been active right from the very beginning of time for the Earth, and will continue to do so, I'm sure, for roughly the same length of time.
Peter, not everyone's going to know just how a volcano works.
The molten lava that fuels any volcano has to get to the surface. And rather like the gas in a champagne bottle that's under pressure until you take the cork off and enjoy the champagne, so the gas that's trapped in the lava beneath the Earth's surface has somehow to escape. So the first thing you have to do is find a weakness, so the lava can come up, the gas can expand, and you have this huge eruption cloud. This is exactly what happened in Iceland. Iceland is probably one of the most volcanically active regions of the world, because it sits on a line where, believe it or not, the Atlantic Ocean is splitting apart. A new ocean floor is forming. And most of the ocean floor is made of the rock basalt. And it is this rock basalt we have a piece of here that we've found is the most common volcanic rock in the entire solar system.
And that bit came from Iceland?
This bit actually came from Iceland. I think you collected it.
I did.
And so you see enormous amounts of basalt on the ocean floor, you see enormous amounts of basalt on all of the terrestrial planets. It's one of the fundamental components of what planets are made of.
So Earth is continuously active. So let's look now, shall we, Peter, at one or two other worlds. Beginning, of course, with the red planet Mars.
Yes.
I mean, I'm plenty of them there.
When you look at a map of Mars, as we now have from spacecraft, there are two huge bulges in the Martian crust, one called Tharsis and one called Elysium.
Yeah.
And interestingly, most of the big volcanoes of Mars are concentrated on these huge two sort of lumps in the Martian planet.
I remember looking at Mars through my telescope, a long time ago, just after the war, I think. There I saw Tharsis all right, but I didn't know what it was.
Well, nobody did, of course, until Mariner went there, and then subsequent spacecraft showed us we had these huge volcanic structures. I mean, Olympus Mons is probably, didn't it used to be called Nix Olympica, if I remember, on the old maps?
The Olympic snow.
The Olympic snow, because there was cloud on the top, which you often saw as a white, like a snow-like shroud. Turned out to be a vast shield volcano.
3 times as high as Everest.
3 times as high as Everest, about 10 times as big as anything we have in Hawaii. And it wasn't alone, because on the same bulge there were 3 other huge volcanoes, Ascraeus, Asia and Pavonis Mons, and they all have one thing in common. They have at their summits these huge depressions called calderas, and that's exactly what happens in Hawaii too.
Now, Peter, those were very active a long time ago. Do you think they'll ever be active again, or is there any activity there now?
There have been some recent results from one of the recent craft using isotope data that suggests possibly there has been some recent activity, but these results are open to different interpretations. My own suspicion is I think that activity is now all over and that Mars is a dead world.
Well, we'll find out finally when somebody actually goes there. I wonder. So, Peter, let's come now to a world that is definitely not dead. And that, of course, is Venus, our twin. We know that Venus is, or was, a highly volcanic world, but is there any activity going on there now? I think there probably is, you know.
We have certainly had some recent data from the Express spacecraft suggesting that there might have been some very young rocks formed at the summit of 3 of the shield volcanoes, and the suggestion has been made by a group of American scientists that this suggests there are recent smooth volcanic rocks to be found on the summits of some of these shields. But I have to say that that is only one possible interpretation. There may well be others. It may have nothing to do with that. When describing Venus these days, we usually show radar maps, and what radar images are, they're representations of the roughness of the surface, and radar does 2 things. It can image the roughness or smoothness of a surface. Smooth surfaces tend to be dark, and on this map the dark low surfaces are shown in shades of blue, and the rough high surfaces are shown in the light colours, the yellows and the reds.
Bear in mind, blue does not indicate sea.
Blue certainly does not indicate sea. If Venus ever had seas, and I suspect it never did, they went off very early in its history.
And we come now to Jupiter and its moons, and there we have Io, the most volcanic world in the entire solar system, a world just a bit bigger than our moon, going around Jupiter, of course, and a very strange place.
When the early spacecraft went out and they started imaging Io, they found these amazing plumes rising from the disk of Io, and it was suddenly realised that these were huge plumes of volcanic material. And once we'd seen one, we began to see that the whole of Io seems to be active more or less continuously.
Well, from Earth, you see Io as a tiny speck. I mean, any small telescope will show it.
Well, that's right. And it's believed that Io resurfaces its whole surface in probably less than 1 million years with what appears to be sulphur.
Well, I don't know, is there anything similar here?
If you go to a volcanic area like Java, you certainly can see little sulphur volcanoes, but on a very much smaller scale. There's one here of Kawah Mas in central Java that I've visited many times, and that does produce little sulphur flows, the longest of which is probably about 7 metres long.
Yes.
So we're talking about a totally different style of volcanism.
Right, going on now to Neptune and the satellite Triton. But it's nothing like our own volcanoes.
Without a shadow of a doubt, now that we have some quite high resolution images of Triton, there are very dark areas, rather irregular, and we believe these are actually active geysers, which are arising through fractures in the silicate and ice surface of Triton, and that they're possibly, it's quite a commonly active world where this is happening most of the time.
The discovery of activity out there was one of the most startling things we've found yet.
Yes, I believe so. We just weren't expecting any of it. I mean, sulphur volcanoes on Io, geysers on Triton, whatever. A science fiction writer have written that story, and yet it's reality.
Peter, thank you so much.
My pleasure, Patrick.
Well, we can see volcanic features on the moon, and Peter and Paul are outside with my telescope to say a bit more about them.
Is that about right, Paul?
Yes, keep going.
Okay.
Put some effort into it.
There's a fantastic first quarter moon out there, you know.
Yes, and it's remarkable what you can see with just the naked eye at first quarter, isn't it?
It is. I mean, you've got the dark features, which are known as maria, or seas.
Which, of course, quite a misnomer because they're completely dry. And the craters as well, some big craters visible to the naked eye. And the maria are interesting things, aren't they? Because we're talking about geology and the volcanoes of the solar system. They're a strange thing, really, aren't they?
They're a bit of a hybrid event, really, because they're caused by an impact event and volcanism. I mean, it's thought that some large body impacted on the moon, created a huge basin, and the collision was so violent that it actually cracked the lunar crust, and lava came out of the cracks which formed and
flooded the whole
filled
basin.
in the basin. So you've got this lovely smooth appearance to the basin.
And I think this month we're going to look at some interesting volcanism regions on the moon, and we have here, look what I found, a wonderful lunar map from Patrick's study.
Now, I have a problem with this straight away because, I mean, Patrick loved it this way.
I liked it as well.
But this is what you look at if you look through a telescope.
Absolutely.
So we turn it around the other way so we can just describe where these things are.
Yes, it's upside down, isn't it? There we go. We can just turn this round.
It's quite a big map.
It is. It's a lovely map. So
what are we going to be looking for?
Okay, so we're going to be looking for domes. These are very interesting things. They're sort of slight upwellings that have come up from the surface. It looks like something's pushed the surface up locally but not broken around it.
Right.
And they tend to occur all over over the moon, but in clusters.
Right.
So we have here a nice lunar map. We can show where some of the most interesting ones are.
Okay, yeah.
So if we go to the crater Milesius, this is very easy to find, look, because it's almost halfway between crater Copernicus and
yes.
Kepler. And just to the west here, there's another nice little collection of domes, which are sort of, again, easily visible in a small to medium-sized power telescope.
When would you see those?
Okay, so the best time, you get 2 shots again, 3 days after first quarter, 2 days after last quarter.
Okay, right. That's quite a good location, actually, because there's another nice crater quite close by. Now, I'm not going to stick with just one dome this time. I'm going to go for a whole field of domes.
You're just a show off.
Now, if we find Copernicus is a very obvious crater.
It
It's got
is,
loads of lovely rays coming out
beautiful.
of it. But if you go down south of Copernicus, there's another smaller but quite well-defined crater called Reinhold. Now, if you go halfway between Reinhold and Miliacus, there's a small crater called Hortensius.
Right.
Now, just to the north of that, there's a lovely dome field called the Hortensius Domes.
I see.
Now, if you look at those with a fairly large telescope and you get the lighting right, similar sort of time to Miliacus, if you get the lighting right, you can see these beautiful curving domes. Now, if you're into imaging and you can get a high-resolution image of this area, you can pick up that each of those domes actually has a little pit in the top of it.
Oh, lovely.
Apart from one, which has no pit,
Right.
and apart from another one, which has 2 pits.
Right.
Now, those pits are a bit odd because they're not like the normal caldera you'd get in the top of a volcano.
No, they're not. And Kuiper had the idea that these may have been extinct volcanoes. I
Right.
don't think anyone's still really sure what these
No,
things
they're a bit
are.
strange, aren't they? They're probably associated with the form. Well, obviously they are the formation, but why one should have no
That's
pits and the other
very,
should have
very
2 is very
strange.
peculiar.
Well, Pete, there's some lovely geological features there on the moon for people with any size telescope to look at.
Absolutely right. And talking of the moon, we had a very interesting lunar eclipse about a week or so ago, and it was a lunar eclipse that kept us guessing right up until the last moment. It's a bitterly cold December the 21st morning. It's about 6:15 at the moment, and I'm anticipating the start of one of nature's finest events, a total eclipse of the moon. Now, as total eclipses of the moon go, this one is quite a special one because it coincides with the winter solstice, the date on which we get the shortest amount of daylight as seen from the UK. Now, the last time that happened was about 400 years ago, so they don't come around that often. Now, this particular total eclipse is going to be quite a challenging one to capture photographically, because as the moon goes into eclipse, it will also be setting. In fact, it sets when the moon is totally eclipsed. That coincides with the sun coming up in the east as well, so it is going to be quite a tricky one to capture in the camera. Now, a total eclipse of the moon occurs when the moon moves into the Earth's shadow in space. Now, the Earth's shadow has 2 components to it. It has a fainter outer ring, which is called the penumbral shadow, and a darker inner ring, which is called the umbral shadow. Now, how dark the umbral shadow is depends on what there is in the Earth's atmosphere, because as the sun's light hits the Earth's atmosphere, some of it gets bent or refracted in, and it infills the Earth's shadow. The darkness depends on what's been going on the Earth itself. And we have had some volcanic eruptions like the one in Iceland, so it'll be interesting to see just how dark this particular eclipse goes. Well, it's just after 6:30 and the eclipse has definitely started. There's a definite edge darkening on the left-hand side of the moon. It's quite a fantastic sight here. We've got the reflection of the moon on the sea and the sky is perfectly clear. This is really getting quite exciting now. But the eclipse is really well underway now. We're very, very close to totality. In fact, it's getting very difficult to actually see much of the moon. This does look like it's going to be quite a dark eclipse. There's a little slither of moonlight left, and in the next 10 minutes or so, the moon will be totally covered by the Earth's shadow. Totality has happened, and for me at least, the moon has gone very, very dark. I'm not entirely sure whether it is just totality or whether the moon has moved into a fog bank close to the horizon. Hopefully someone further to the west of me will be getting more luck and they'll see the moon in totality higher up. Now, it was definitely reddish in colour. Now, recently we've had some volcanic activity, such as the volcano in Iceland, so that could well be affecting the darkness and the colour of this totality. Well, that's it. The moon's disappeared. I'm actually quite astonished. I wasn't expecting it to just disappear completely from sight, but I can't see it at all. It's been quite an incredible eclipse. I'm very lucky. I've got some great pictures, and hopefully other people will have some too.
Well, Pete, that was a lovely lunar eclipse. They don't come like that very often, do they?
We were really lucky with the weather, weren't we?
And we have some wonderful events to look out for this part of January, don't we?
We do. If you go out on the 3rd and 4th of January, there's some very interesting things happening. On the night of the 3rd, going into the morning of the 4th, we have another meteor shower to look forward to, which is the
Quadrantids meteor shower. And this is a very nice one, isn't it?
It's an interesting one because if you observe from midnight on the 3rd through to dawn on the 4th, you have to wrap up really warm. It's a cold January night. Get a sunbed, sounds a bit strange to take that out, lay back and just watch the skies and look for these really swift meteors. Those are the quadrantids. But they build to a very sharp peak, which is just a few hours in width. And you might see up to, say, 120 meteors an hour.
Oh, goodness, that's quite a few meteors, isn't it? And of course, if you've stayed up to see that, you might as well stay up a bit longer to see the main event, a partial eclipse of the sun.
We're really lucky. We had an eclipse in December of the moon, and now we've got a partial eclipse of the sun. Now, this one occurs when the sun is rising above the southeastern horizon. You've got to be really careful, of course.
You have here. The temptation is, of course, to look at it through a telescope or binoculars because it's slowed down. You can't feel any heat from it, but that is still enough to do some damage to your eyes. So you must never ever do that.
You've got to use proper certified filters to look at it.
Absolutely.
Now, the sun rises about 10 past 8 from the south east of England, and a bit later if you're up in Scotland. I think it's about 8:40 or so. And there's quite a big chunk of the sun covered up by the moon, if you can watch that. And then about 9:30, the whole thing is over.
But a notable portion of the sun is gone, isn't it?
From the southeast, it's about 65% by area, I think.
And so if you decide to continue on without any sleep, that bright object in the evening sky later on, the planet Jupiter.
And Jupiter's fascinating at the moment. If you've got a small telescope and look at it, it's had a missing belt, hasn't it?
That's right. The southern equatorial belt, for reasons only known to Jupiter, vanishes, and now it's making a dramatic comeback. So the traditional bright white spot was seen, and now the turbulence is spreading, and you're getting these darker regions, and slowly but surely the southern equatorial belt will dramatically reappear.
And of course, if you look at Jupiter with a pair of binoculars, the little dot just above it is the planet Uranus.
Now, we really ought to be making the most of this because the two planets they're closest together, aren't they, this year?
They are, and that will be January the 4th, night of January the 4th. That's the last time they'll be that close together until April 2024.
So really go out and take a good look at it and make the most of it.
Well, this month we have some very brief news notes over to Chris North.
On Saturn's moon Titan, the Cassini spacecraft has possibly spotted a cryovolcano for the first time. We were talking about these icy volcanoes earlier in the programme, but this is the first time we've seen one on Titan. In this radar image, which sees through Titan's thick clouds, a mountain, a crater, and possibly even the equivalent of a lava flow can be seen. The material spewing out isn't molten lava, but could be slushy, methane-rich water with a consistency similar to soft candle wax.
Chris, thank you very much. Don't forget our webpage. People find that very useful. It's bbc.co.uk/sky at night. And when I come back next month, I'll be talking about that lovely constellation of Orion. So until then, good night.